All right, let's go over example 2 of finding the domain of a quotient of two functions. In this case, we have two rational functions. So to find the domain of a rational function, we take each denominator and we set they're not equal to 0 and solve for x. In this case, the denominator we have here is just the x. So really, the domain of this function is just x cannot be equal to 0. And the domain of this function is x plus 2 cannot be equal to 0. Solving for x, we have x cannot be equal to -2. And the interval notation for this one is going to be from -infinity all the way to excluding 0, which is an open interval. And then from excluding 0 all the way to infinity, which is another open interval. And the same thing can be said for this one. Now let's find f of x over g of x, which is just 6 over 1 minus 1 over x, and then 1 over x plus 2. Now in this step, the restrictions are that x cannot be equal to 0, and of course x cannot be equal to -2, such as up here. And the reason why we want to find the restriction at every step is that we want to make sure that we exclude all of the x values such that every step of our simplification process is not undefined. To simplify this even further, notice that 6 by itself is the same as 6 over 1. Finding the common denominator by making this denominator turn into the same as x here by multiplying this denominator by x and the numerator by x as well. The next step is going to be 6x over x minus 1 over x, and then all over 1 over x plus 2. And of course, for this second step, we can tell right away that x cannot be equal to 0 and x cannot be equal to -2 again. And then since we have a common denominator, make it as 1. Same denominator. So we got 6x minus 1 over x, and then all over 1 over x plus 2. We have fraction divided by another fraction, so the way we change this division into multiplication is by keeping the numerator fraction the same. Write the multiplication sign, and then multiply this by the reciprocal of the denominator fraction, which is just x plus 2 over 1. In this case, we can tell right away that x cannot be equal to 0. And of course, up here, x cannot be equal to 0, x cannot be equal to -2. And then x cannot be equal to 0 in this case. In this step, I say. And I just multiply across. We got 6x plus 1, 6x minus 1 times x plus 2 all over x times 1 is just x. And this step, x cannot be equal to 0. So let's fold it out. Let's see, 6x times x is going to be 6x squared. 6x times 2 is going to be 12x. -1 times x is going to be -x. 12x plus -x is going to be just plus 11x. -1 times 2 is going to be -2. And all over x. And that's going to be equal to 0. So taking the restriction of both the function f, the restriction of function g, and the restrictions of every step of this simplification process into consideration, we know the domain of f of x and g of x is going to be all real numbers except that, I should say all real numbers except that x cannot be equal to 0 and -2. So let's do the same thing, but we are going to find g of x divided by f of x. But we know that g of x is 1 over x plus 2 divided by 6 minus 1 over x. And of course, at this step, we know that x cannot be equal to negative 2 and x cannot be equal to 0, just like how we did it earlier. And then, of course, finding the common denominator, I should say, just as we did earlier, we know that this one is going to be equals to 1 over x plus 2, all divided by 6x minus 1 over x. And we know x cannot be equal to negative 2 and 0 again. And then changing this division into multiplication by keeping the numerator fraction the same and changing this denominator fraction into its reciprocal, we are going to have 1 over x plus 2 multiply x over 6x minus 1. And hey, at this steps we have x cannot be equal to negative 2, and we have 6x minus 1 cannot be equal to 0. So technically, oops, wait, what am I writing? So we also have x cannot be equal to 1 over 6. And you see, it's very important that we had to find the restriction of every step of the simplification process when we deal with a fraction of two functions, because we want to make sure that we exclude all of the x values in order to make sure that this entire division is not undefined at every step, or is always defined at every step, I should say. So we get x cannot be equal to 1 over 6 right here. So multiplying these two fractions, we're going to have 1 times x, which is just x, all over, well, we did this earlier, it is going to be 6x squared plus 11x minus 2. And of course, the restriction at this step is going to be the same as up here, because this is just the product of these two denominators. So we get x cannot be equal to negative 2 and 1 over 6. Now, let's graph it on the number line. On the number line, well, we have, let's see, we had a function f here, function g here. So let's put negative 2 right here and 0 right here. And to graph the domain of the function f, if we take a look, the domain of the function f only excluding x cannot be equal to 0. So, and of course for the function g, x had to exclude negative 2. So for the function f, just like you saw earlier, it's going to go from negative infinity to excluding 0, which is the open circle like you see. And then it's going to go from excluding 0 all the way to positive infinity. So this is the domain of the function f. And for the domain of function g, well, it is excluding negative 2. So it's going to go from negative infinity to excluding negative 2, which is the open circle, and then from excluding negative 2 all the way to positive infinity. The domain of the function f and g graphed out right here. And we already found that the domain of f of x over g of x is all real numbers except for x cannot be equal to 0 and negative 2. And of course, x cannot be equal to 0 and negative 2 are all restrictions that we have in f of x and g of x, because in domain of function f, x cannot be equal to 0. In the function g, x cannot be equal to 2. And in every step of this simplification process, x cannot be equal to 0 and negative 2, as you can see here. So the domain of both the function, the domain of f over g is going to be all of the x values in common and all of the restrictions of both functions. And of course, from every step of the simplification process earlier, as mentioned, So the domain of the function f over g is going to go from negative infinity to excluding -2, union to jump to the next part from excluding -2 all the way up to 0, but not including 0. So another open interval. And then union side to jump to the next part, going from 0, but not including 0, and then to infinity, another open interval. So this is the interval notation for the domain of f over g. Now what about for g over f? Well, sketch another number line and put -2 and 0. And of course, we know that the domain of the function f is, again, all real numbers, except that x cannot be equal to 0. So it's the domain of function f. And the domain of function g is all real numbers, except x cannot be equal to -2. Just like you saw earlier. So because all of the restrictions from the function f, from the function g, and from every step of the simplification process to get down to this result are only x cannot be equal to -2 and x cannot be equal to 0. And of course, x cannot be equal to 1 over 6. We also have to make sure that we include 1 over 6 in there. So maybe it's going to be, I want to say 1 right here. So 1 over 6 is probably somewhere right here. We can tell right away that the restrictions are going to be here, here, and there. So taking all of the restrictions into consideration from the function f, function g, and from every step of the simplification process, we have the domain that looks something like this. So what about the interval notation? Well, from left to right, from -infinity to up to -2, but not including -2, we have -infinity, comma, -2, and then parentheses on both ends. Union side to jump to the next part. We're going to go from excluding -2 all the way to excluding 0. Union to jump to this little part. This little part is from 0, but not including 0, up to 1 over 6, but not including 1 over 6. So that's another open interval. And then union again to jump to this last part, from 1 over 6, but not including 1 over 6, all the way to positive infinity. And this is the interval notation of the domain of g over f.